Come with me as I build a machine learning model that predicts bank loan approvals. Our first step is always to get our data. Today, I'm just using a simple data set from Kaggle by Analyticspedia. Let's take a look at our training data. We're looking at metrics like whether the applicant is male or female, whether or not they're married, their dependents, education level, and so on and so forth. At the very end, we see a column called loan status, and this is the label that the model is trying to predict. Essentially, it looks at these metrics and outcomes for almost 400 applicants and keeps adjusting itself and fixing itself until it works well enough to predict these correctly. Next, it's time to open our coding environment. Today, I'm using Jupyter Notebook, but you can also use Visual Studio's Code, Sublime Text, or any other environment you like. Let's import our tools. First, Pandas is for tables, so think Excel and Python. We're using NumPy for anything related to arrays and math, and we're importing tons from scikit-learn because it's our machine learning toolbox. We're going to use it to split data, pre-process, build the model, evaluate, tune, and more. Lastly, Joblib is for saving and loading the trained model so that we can reuse it again easily. Now, before we dive deeper into this, we have to make sure our data is clean, and part of this is making sure that our column names are consistent. Sometimes CSV headers arrive abbreviated, so let's fix this. We're writing a function called normalize headers, which simply scans each column name, recognizes common prefixes, and renames them to a clean version. Now let's get into feature engineering. Feature engineering is when we create or clean inputs to make patterns easier for the model to learn. For example, in the dependents column, we have values written as 3+, which we can just convert to the number 3. Another example is combining the two income fields into a single total income and comparing the loan amount to that income so that the model sees how big the request is relative to earning power. Now we actually split our data into training and testing sets. Typically in machine learning, 80% of the data goes to training and the other 20% to testing, so we're staying consistent with that today. Next, let's get into something called pre-processing. Essentially, we're building a column transformer that replaces missing numerical values with the median and scales them, and replaces missing categorical values with the most frequent value and does some one-hot encoding. Now let's get started on the model itself. Today we're using logistic regression because it's fast, reliable for yes or no outcomes, and gives us probabilities. First, we're fitting the pipeline on the training set itself. This is exactly where the model is learning the pattern. It's just one line of code, but it really carries so much of the machine learning model behind it. After this, we immediately evaluate on the validation set. We're tracking accuracy for overall correctness, precision to check how many of the predicted approvals were actually approvals, recall to see how many of the real approvals were caught by the model, and ROC AUC to judge ranking quality across thresholds. To make results more stable, we're also running a 5-fold cross-validation. Essentially, we're training and testing on 5 different splits and then averaging the scores. We're also doing a tiny hyperparameter search to really squeeze out the best performance out of the model and of course avoid overfitting. Now, once we finally pick the ideal setting, we're refitting the best pipeline on all these labels so that we can ship the strongest model. Then we save it with Joblib. Saving this pipeline means the pre-processing and the classifier travel together so that when we load it later, it just works. We don't have to pre-process over and over again. Lastly, our test data includes all of those same metrics that we looked at in our trained data, but it doesn't have that loan status column. This is because we want to see how well the model can predict whether or not the bank loan was approved on its own without any cheat sheets. So we're loading this test data, running the same header normalization and feature engineering just like we did before. We're feeding it through that saved pipeline, and we're outputting a CSV with columns called loan status prediction and approval probability. This will of course tell us whether or not the model thinks the loan will be approved and its overall guess for how likely it is that it will. And with that, congratulations, we've officially built a machine learning model together. If you want to see this model run on real-world examples, make sure you stick around for part 2. See you then.